Hello students, in the previous lecture we had done the problems of direct central impact and we had also done the three problems on oblique central impact. For the direct central impact between ball and the plane, we had understood that with every direct central impact between ball and the plane, velocity of the ball changes by e times. Direct central impact means what? The ball hits the plane at 90 degree to the plane. But if the ball hits the plane at any angle other than 90 degree, it is not normal to the plane, then such an impact is called as oblique impact. So now we'll discuss few problems of oblique impact between ball and the plane. To solve these sums, we have to first remember this note. I'm reading this note. During oblique impact between ball and plane, velocity component along the plane remains same because that becomes your tangential component, and the normal to the plane changes by e times. Normal to the plane changes by e times. All right. Now, with this note, we are in a position to solve the problems of this kind when there is an oblique impact between ball and the plane. What do you mean by oblique impact? Ball hits the plane at any angle other than 90. Like in this problem, you can see that ball is hitting the wall at 30 degree with the horizontals. So obviously 60 degree with vertical. That means it is not 90 degree. So this impact is called as oblique impact. Now we read this problem. A ball is thrown against a frictionless wall. Its velocity before striking the wall is as shown in the figure. Knowing that E is 0.8, determine the velocity after impact. Students, you can see that ball is hitting the plane at a velocity of 10 meter per second, which is at 30 degree with the horizontal. Now before impact, we'll resolve this velocity. The velocity component along the plane will be 10 sine 30. If you resolve it, 10 sine 30 will be vertically up, so it will be along the plane. So that is 5 meter per second. Velocity component normal to the plane will be 10 cos 30 towards left. 10 cos 30, 8.66 towards left. Now this is the status of the components before impact. Now we write the heading after impact. After impact, which component remains same? Along the plane. So velocity component along the plane is 5 meter per second. Velocity component normal to plane will change by e times. Multiply by e and direction will be reverted. Before impact, it is towards side. After impact, it will be in opposite direction. So 8.66 into e is 0.8, 6.928 meter per second. Now you have to just simply find the resultant of these two components of the velocity. Component along the plane, I mean vertically up, is 5 meter per second. Component normal to the plane is 6.928 meter per second. So we can find resultant velocity. Resultant velocity will be square root of 5 square plus 6.928 square. You get 8.554 meter per second. Then you can find the angle, what the resultant velocity after impact makes with horizontal. Tan theta is 5 upon 6.928. That comes 35. So the ball which is hitting with a velocity of 10 meter per second at an angle of 30 degree with the horizontal before the impact, after impact its velocity is 8.554 meter per second, and angle what it makes with the horizontal is 35.82 meter per second. All right. Let's move to the next sum. Little more working, little more steps will be involved in this sum. Again, it is an oblique impact between the ball and the plane. This time the ball will hit the plane vertically down, but the plane is not horizontal. If this plane is horizontal, then velocity of the ball just changes by e times. So here what we'll do that we'll first find the velocity of the ball just before impact. Then we'll resolve it along the plane and normal to the plane. And then we'll keep it in mind, the component of velocity along the plane remains same and normal to the plane changes by e times. Now I'm reading the sum. The ball is dropped from the height of 5 meter on the inclined surface of 30 degree inclination. Find the velocity of the ball after impact. Take E is equal to 0.8. Now this is dropped from the height of 5 meters. So first we'll find the velocity with which it is hitting the plane. So we'll take downward positive. E square is equal to u square plus 2s. U is 0, dropped. And s is 5 meter. G is positive. Acceleration due to gravity. We are taking downward positive. So you get V square is 0 square plus 2 into 9.81 into h is 5. So you get velocity 9.905 meter per second vertical down. So at this point, V is the velocity of the ball just before impact is 9.905 meter per second. We need to resolve it along the plane and normal to the plane. This plane is making 30 degree with the horizontal. So normal to the plane, and normal to the plane will make 30 with vertical. Again, I repeat, this plane is making 30 with horizontal. Normal will make 30 with vertical. So component of this velocity just before impact, V, along the plane is going to be V sin 30. And normal to the plane will be V cos 30. So I'll write it down. before impact. Write the heading before impact. Velocity component of the ball along the plane. What is that going to be? 9.905, because this is vertically down. This is 30 degree with normal. So this component will be sine. So 9.905 sine 30, 4.952. It is at 30 degree with the height. What will be velocity component of the ball normal to plane? 9.905 cos 30. It will be 30 degree with the vertical. You can see that. Whereas the plane is 30 degree with the height. In this way, along this. Now, after impact, which component remains same? Along the plane. Along the plane remains same, 4.942 meter per second, and plane is making 30 degree horizontal. Velocity component normal to the plane will change by e times, and the direction will be absolutely reversed. 8.577 into e is 0.8, you get it 6.862 meter per second. This is 30 degree with the vertical. See, before the plane, it will be this way. After the impact, normal component will be exactly in opposite direction. Okay. Now you'll find the resultant of it. Just draw x and y lines, which I have shown dotted. Along the plane, component remains same, 4.95, 30 degree horizontal. Normal is 6.86. Obviously, both are mutually perpendicular, because along the plane it is 30 with horizontal, normal with 30 degree with vertical. So, and they are mutually perpendicular. So I can find their resultant velocity. Resultant velocity will be square root of 4.952 square plus 6.86 square. Square root of that 8.462 meter per second. We consider its angle, what it makes with the direction of plane is theta. Tan theta is going to be 6.862 upon 4.95. Theta is 54.1. But when we give the answer, normally we do not give the normal practice is to give the answer of angle either with horizontal or with vertical. So you can see that theta is the inclination of the resultant velocity with the plane or with the component along the plane. But we want with horizontal. So here this component along the plane is making 30 with horizontal. You want to find the angle of the resultant velocity with horizontal. So theta plus alpha is 30 plus alpha is theta. So what will be alpha? Theta minus 30. So theta is 54.18 minus 30 is 24.1. So we understood that resultant velocity makes an angle of 24.18 degree with the height. That is angle alpha. All right. Well, students, after this, we'll take the problems of result combined concept. The first type of the combination what we come across here is combination combined concept problems where impact concepts are clubbed with projectile. Impact and projectile concepts are clubbed. So here I'm taking just one problem. With that you get the fair idea how we solve this kind of the problems. Let's see. A small steel ball is to be projected horizontally such that it bounces twice on the surface and lands into a cup placed at a distance of 8 meters as shown in the figure. If the coefficient restitution for each impact is 0.8, determine the velocity of the projection u of the ball. Now you can see that this is the diagram given. This height is 2 meters. From this height u, the ball is projected horizontally. If the ball is projected horizontally, then it will follow the, it will be a projectile motion. It path space will be parabolic. Then it will hit the ball. The ball will hit at some angle, which the resultant velocity makes with the horizontal vertical. Then after impact, now at this stage there is an impact. Then after impact you need to find the velocity. Then again it is projectile motion. Again at this stage there will be impact, and then again it lands into the total distance after three. You can say after third. This is first impact, the second impact, and this is the third one. At third impact level, there is a cup sort of where it is landing into that cup. So we'll have to apply the equations first, projectile motion from A to B. I have to apply impact at B. Then I have to take B to C projectile motion. I have to apply impact principles at C. And then it lands into it. Then I have to take projectile motion from C to D. All right. At B, it is oblique impact. At C, it is oblique impact. I'm considering when projectile is thrown horizontally, vertical component velocity is 0, which we have marked it as 0. I'm taking A to B, horizontal distance is x1, time t1. B to C, horizontal distance is x2, time taken is t2. C to D, horizontal distance x3, time t3. x1 plus x2 plus x3, total distance between A and D. Total horizontal distance between A and D is 8 meters. That's what is given. Now we start with projectile motion from A to B. First, we take vertical motion. S is equal to ut plus half m square. S is 2 meter. Use vertical component velocity at A0. Acceleration due to gravity plus half into g into t1 square. You get the value of t1 as 0.6385 second. Now, we get vertical component velocity using v is equal to u plus c. V is vy. We are taking vertical motion. U0 plus 9.81 into t. That is 0.6385. That comes 6.264 meter per second. During projectile motion, horizontal component velocity remains same. X1 will be u into t1. U into t1, you got this x1. The velocity of the ball at B. This is after impact. After impact, what happens? Horizontal component of velocity remains same, x component, and y component of velocity will change by e times. You have understood horizontal component velocity throughout will remain same, that is along the plane. Normal to the plane, that is vertical component before impact is 6.264. All right. Then after impact, horizontal component remains same, vertical component will change by e times. E is what is 6.264 e. E value is 0.8. So at B, velocity of the ball after impact is 5.011 meter per second upward. This is vertical component after impact. This is horizontal component after. Now we'll take projectile motion from B to C. I'll take upward positive. I'm taking vertical motion as equal to ut plus half. When I take projectile motion from B to C, there is no vertical displacement, so S is 0. Initial vertical velocity is 5.011 into T2 minus acceleration due to gravity will be minus, since we are taking upward positive, half into G into T2. So that you got T2. Then you got X2. X2 is what? U into T2, 1.02. Now velocity at C after impact. Horizontal component of the velocity again remains same. Vertical component of the velocity will change by E times. Vertical component of the velocity will change by E times. So how you pick it up? 5.011 is the velocity, you got it at B. All right. As so 5.011 is the velocity at when we take velocity C, horizontal component velocity remains same. All right. And the velocity with which it vertical component velocity is 5.011. So velocity of the ball at C is going to multiply by E, 5.011 E, 5.09. Then we take motion from C to D. When we take motion from C to D, again vertical motion S equal to ut plus S is 0. Initial vertical velocity is 4.09 into T3 minus half into G into T3. So you got T3. Then X3 is horizontal component velocity remains same. That is U into T3. You got 0.834. Given X1 plus X2 plus X3 is 8. All right. So then we substitute the value here. That is X1 is 0.6385 U. X2 is 1.022 U. And X3 is 0.834. All right. And this is given equal to 8. So if you solve this equation, it was given here, students, X1 plus X2 plus X3 is 8 meter. X1, X2, X3 are expressed in terms of U, and then you get the value of U as 3.21 meter per second. All right. Now we'll take now another combination of the problems on combined concept is what is impact and work energy principle. There are many problems, many types of problems we come across on this. Problems on combined concepts. Now that is work energy principle plus impact. In this type of problems, apart from impact, work energy principle will also be used. Now I'm reading this. A pile of 400 kg mass is being driven into the ground with the help of a hammer of mass 1000 kg. Hammer falls through a height of 2.5 meter, assuming plastic impact. Plastic impact between hammer and pile. That means after impact, hammer and pile will move together with a common velocity. Find the number of blows required to drive the pile by 1 meter when the resistance offered by the ground to penetration is 300 kilo. All right. Now, students, this was the diagram given. This is hammer falling from the height of 2.5 meter onto a pile of 400 kg. Resistance offered by the ground is 300 kg. Now, I have drawn a diagram which is I have put more sense into that. So, this is the pile. See, what is a pile basically? To understand this problem, you should understand what is pile, what is hammer, where this system is used. See, one of the there are two types of the foundation for civil engineering structures like buildings, bridges, and all. One is called as open excavation foundation, where the entire area is excavated and foundation made up of concrete, steel is laid and it is buried under the ground. All right. Over there, it is excavated and foundation laid. Another type of foundation, which is very common these days, is pile foundation. In the pile foundation area, where the building or bridge is to be constructed is not excavated completely. With then, what is happening? The pillars, which we call it as piles, they are having conical shoe at the bottom, as you can see over here. So, number of such piles, pillars are erected into the ground without excavating the ground. So then what happens when this pile reaches sufficient depth? So there will be some ground resistance offered by the soil to the pile. So that this pile is in a position to take care of the load. Sometimes this pile will touch some hard surface, then also it can take the load. So this way number of piles are erected at very close interval. And then a pile cap, we can call it, is constructed like a slab. Then the foundation base is ready. So this is the pile foundation where pile is being driven into the ground. Pile driving process is going on. So this is 1000 kg hammer. This hammer is operated using a cable and a motor. Right here, it has not been shown in the question, but we have made it in a proper way. So this 1000 kg hammer is connected to a cable and it is taken around a pulley which is fixed in position. Only it allows the cable to rotate. On this side, there must be a motor. From 2.5 meter height, hammer falls. Then there is a pile of 400 kg mass. This is ground resistance to penetration. Now, right, I'll have to apply work energy principle from 1 to 2. 1 is the position when a hammer starts falling from zero velocity. In position 2, we get the we'll get the velocity of the hammer with which it hits the pile which is at rest. So now U12 is equal to T2 minus T1. 1000 into 9.81 is the weight of the hammer into 2.5 is equal to change in kinetic energy, half into 1000 into U square minus 0. It starts from rest. In position 1, velocity is 0. U is the velocity of the hammer in position 2. Or we can say it is 7 meter per second. This is the velocity of the hammer just before impact. Okay. Now plastic impact between hammer and pile. What is the hammer mass? 1000 kg. What is its velocity? 7. Pile mass 400 kg. Its initial velocity is 0. But since it is plastic impact, after impact, velocity of the pile and hammer will be same. So M1 U1 plus M2 U2 is equal to M1 plus M2 U2. So 1000 is the mass of hammer into its velocity, taking downward positive, plus 400 kg pile into 0, since it is a rest, is equal to M1 plus M2, 1000 plus 400 into 0. This way you got the 5 meter per second. This is nothing but velocity of the pile and hammer just after impact. All right. Now, from 2 to 3. Now, pile and hammer will move together now. We consider that X is the penetration of the pile in one blow. We are considering that X is the penetration of the pile in one blow. So now we apply work energy principle from 2 to 3. 1000 plus 400, that is mass of the pile and hammer, into 9.81. It gets converted into weight into X. X is the penetration of the pile in one blow. Right? This weight of the pile and hammer will do positive. This ground resistance 300 into 10 raised to 3. It is in kilonewton. I have to convert into Newton. 300 into 10 raised to 3 into X. Weight of pile and hammer will do positive work as weight will act downward. Ground resistance will be acting upward in the direction opposite to that of displacement. So it will do negative. Is equal to T3. Entire system comes to rest in position 3. T2 half into total mass of the system 1000 plus 400 into V. V is 5. So this way you get penetration of the pile in one blow, 0.0611. He is asking you to find out number of blows required for 1 meter penetration. See, in one blow, penetration is 0.0611. So number of blows required for 1 meter penetration will be 1 meter divided by 0.0611. So it is 16.36 blow, but we cannot leave it as it is. You cannot round it on the lower side. You have to round out on the higher side. So we'll have to say we cannot leave the answer at 16.36 blows. We have to answer 16 or 17. But 16 will be wrong answer because in 16 blows, 1 meter penetration will not happen. But on 17 blows, yes, 1 meter penetration will happen. So correct answer is 17 blows, not 16. We have to round off on the higher side. Okay, we take another sum, which is also on combined concepts. And what are the concepts involved in these sums? Work energy and impact. The bullet traveling horizontally with a velocity of 600 meter per second and weighing 0.25 Newton strikes a wooden block weighing 50 Newton resting on a rough horizontal floor. Uk is 0.5. Find the distance through which the block is displaced from its initial position. Take G is 10 meter per second. The bullet is coming with the velocity of 600 meter per second. Its weight is 0.25 Newton. It is hitting a block of 50 Newton, which is resting on the plane, which is rough. Now, first we'll consider impact between bullet and block. And what kind of impact will be? Plastic. What kind of impact it is? Plastic impact between bullet and block. Right? What is the mass of the bullet? 0.25 upon 10. So 0.025. What is the mass of the block? 50 upon 10. 5. Taking towards right as positive, U1 is plus 600 meter per second. That is initial velocity of the bullet. Block is at rest, U2 is 0. Let V is the velocity of the bullet and block after impact. Since the bullet gets buried into the block means what? This is plastic impact between bullet and bullet. All right. Now, we consider M1 U1 plus M2 U2 is equal to M1 plus M2. This is mass of bullet into its velocity. Mass of block into 0 since it is at rest. M1 plus M2. Mass of bullet plus mass of block into. So V is the common velocity of the bullet and block just after impact. Now to find the distance by which this block will be moving towards right, we will use work energy principle. So I draw free body diagram of the block. Weight vertically down, normal reaction upward, motion is to the right, friction is to the left. All right. We identify this as position 1 when velocity is 2.985 meter per second. How long it will keep on moving towards right? Till it comes to rest. So in second position, first, how do I see work energy principle is always applied between two positions. How do you identify two positions? Where velocities are into conservation. In position 1, velocity is 2.985 meter per second. This is the velocity of the bullet and block just after impact. How long this block will keep on moving to the right till it comes to rest. So we are considering that block moves towards right by distance s and then it comes to rest. Now on this block, if you apply sigma Fi is equal to 0, N1 is equal to 50.25 Newton, U12 is equal to T2 minus T. Minus 0.5 N1. Friction will do negative work. Weight and normal reaction will not do work. Minus 0.5 N1 into S is equal to, that's it. There is no other force which will do the work. T2 is 0 minus T1 half into total mass 5 plus 0.025 into velocity. What is velocity? 2.985 square. Putting N1 is equal to 50.25 Newton. If you solve, use calculator, that is 0.89 meter is the value of S. That means after the impact between bullet and block, entire system will move towards right by a distance of 0.89. So this problem had the two steps working. First step was impact, that is plastic impact between bullet and block, and second step was work energy. We'll take many more problems of this type because this is an important combination as per us. Okay, move to next problem. That is problem number 6. A 2 kg sphere A is moving to the left with a velocity of 15 meter per second when it strikes the vertical face of a 4 kg block, which is at rest. The block B is supported on the rollers and is attached to the spring of constant K 5000 Newton per meter as shown. Now, further, it is given in the problem. E is the coefficient restriction for the block and plane is 0.75. That is also given. Determine the maximum compression or shortening of the spring due to impact magnetic. Students, E is given as 0.75 in the problem. K is given 5000 Newton per meter for this spring, which is attached to block B. All right, and it's connected to the plane. Initially, block B is at rest. Its mass is 4 kg and it slides without friction. 2 kg sphere is traveling to the left and its velocity is 15 meter per second. So that is its velocity just before impact. So we'll consider first impact between A and B. This will be direct central impact. All right, taking towards left as positive. MA is 2 kg, MB is 4 kg, UA is plus 15 and UB is 0. So MA UA 2 into 15, MB UB 4 into 0. So because block is rest. 2 VA, MA VA plus MB VB. 2 VA plus 4 VB is 30. E is VB minus VA upon UA minus. E is 0.75, VB minus VA, UA is 15 minus 0, you get VB minus VA is 11. Solving these two equations, you get velocity of block A minus 2.5, that is 2.5 meter per second. We don't need velocity of block sphere. Velocity of block B is 8.75 meter to the left. This is what we needed for the solution of the problem. Now, to get the maximum compression, see, after impact between A and B, block B attains the velocity of 8.75 meter per second towards left. So that will take as position 1 for the block. Second position will be identified as the position of the block when it comes to rest. See what happens. This is the block on which weight will act vertically down, normal reaction will act vertically up, friction is 0. In this position, velocity is 8.75 meter per second. This block as it has gained the velocity 8.75 meter per second, it will continue to compress the spring till it comes to rest. At that stage, compression of the spring will be maximum. All right. So X is the maximum compression due to impact. Now, when the block is in position 1, we'll apply work energy principle between 1 and 2. In position 1, deformation of the spring is nil, so X1 is 0. In position 2, deformation of the spring is X. So we apply work energy principle between 1 and 2. Mind it that weight will not do work, normal reaction will not do work, right? Friction is not there, so only spring force will do the work. What is work of spring force? Minus half K, K is 5000, X2 square minus X1 square is equal to T2 is 0 because block comes to rest. T1 is half M4 into V square, what we got in 8. If you solve it, you get X as 0.2475. So maximum compression of the spring is 0.2475 and then block comes to rest. Next problem number 7 of this lecture. A bullet of mass 20 gram and moving horizontally with 800 meter per second strikes a bob of wood of mass 5 kg suspended by a wire of 2 meter length. To what angle with vertical will the block embedded bullet swing? That means, can you see that here? This is the bob given to you. It is connected to a cord of length 2 meter. Then there is a bullet which is going to hit it with a velocity of 800 meter per second. Then the bullet gets embedded into the block. If the bullet gets embedded into the block, bob, that means it is a plastic impact. So we will consider plastic impact between bullet and bob. Then we'll find the velocity of the bullet and bob just after impact. Then we'll apply work energy principle so as to get the angle what the cord is making with the butt. Theta is required. It is written as the bullet gets embedded, it is a case of plastic. So plastic impact between bullet and bob. Bullet is taken as given index 1, bob is given index 2. Mass of the bullet is 20 gram, 20 upon 1000, it is 0.02. Mass of the bob is given 2 kg. Taking towards right as positive, U1 is the initial velocity of the bullet, 800 meter per second. Bob is at rest. M1 U1 plus M2 U2 is equal to M1 plus M2. M1 is mass of the bullet into its velocity 800 plus mass of the bob into 0, so it's bob is equal to M1 plus M2, 0.02 plus 5. V is 3.187 meter per second. V is the velocity of the bullet and the bob just after. Now we'll apply work energy principle. This string is of 2 meter length. Here there is a bob. We take this as position 1. When it gains the velocity, we are considering just after impact, its velocity is 3.187 meter per second. As this bob is connected to a string of length 2 meter, it will start swinging along a circular path like this, dotted line. And how long it will keep on swinging? Bob has gained the velocity of 3.187 meter per second. and it will continue to swing till it comes to rest. So in position 2, velocity is 0. All right. Now this length is 2 meter. This length is 2 meter. So this angle is theta. So in this right angle triangle, this length will be adjacent. In this right angle triangle, hypotenuse is 2 meter. So this adjacent side is 2 cos theta. So vertical displacement between 1 and 2 position. 2 is the position when the bob comes to rest. What is vertical displacement? 2 minus 2 cos theta. So this is 2 minus 2 cos. Now apply work energy principle from 1 to 2. Weight of the bullet and bob will do negative work. 5.02 kg is mass into 9.1, it gets converted to weight into vertical displacement 2 minus 2 cos theta. Weight acts downward, displacement upward, work done is negative. Is equal to T2 0 as system comes to rest minus half mass of bullet and bomb into velocity of the bullet and bomb just after. If you solve and simplify, first you'll get 1 minus cos theta is 0.2588, then you get cos theta and then theta is angle. So theta is the angle what the this cord or wire makes with the vertical when it comes to rest. So this is the maximum angle. To what angle the block will be able to swing. So this is the angle by which the bullet embedded into the bob will swing, because then the system comes to rest. This type of problems are also asked many times in our examinations. We'll take some more problems on this. I read it. A 30 kg block is dropped from the height of 2 meter on a 10 kg pen of a spring scale as shown in the figure. Assuming the impact to be perfectly plastic, determine the maximum deflection of the pen. Consider a constraint of spring is 20 kilonewton per meter. Take G is equal to 10 meter per second square. Now this is the 30 kg pen. It starts falling from the rest. It falls by 2 meter. Then there is a 10 kg pen. This 10 kg pen is kept on the spring. Due to the weight of this pen, there will be some initial deformation of the spring that you should always calculate beforehand. So 10 kg pen is kept on the spring of stiffness 20 kilonewton per meter. So as F is equal to Kx, so initial X will be equal to F upon K. So initial compression of the spring will be what? Weight of the pen 10 into 10. K is 20,000. So 0.005 meter is initial compression of this spring due to the weight of the pen kept on it. Now we'll apply first work energy principle from 1 to 2. We'll first apply work energy principle from 1 to 2. T12 is equal to T2 minus T1. 30 into 10 is the weight of the block falling by 2 meter. Work done is positive, weight downward, displacement. T2 is half into velocity mass is 30 into V2 square minus 0. V2 is 6.325 meter per second. V is the velocity of this block just before impact or in position 2. Now we'll consider plastic impact as it is given in the problem. It is a case of plastic impact. That means both block and the pen move together with the common velocity after plastic between A. I take downward positive. 30 is the M1 U1. 30 is the mass of the block into 6.325 plus 10 kg is the mass of the pen into 0 since it is equal to M1 plus M2. 30 plus 10 into V dash. So V dash is 4.743. V dash is velocity of the block and pen just after impact. Now we consider let X be the maximum compression of the spring after impact. All right. Now X1 is already known to you when the block is in position 2. All right. Deformation of the spring was already there 0.005 meter. When the block further compresses the spring by X, deformation of the spring will be X plus 0.005 meter. So you apply work energy principle from 2 to 3. This is weight of the block and the pen for 40 kg into 10, 400 meter into X. Weight of the block and the pen will do positive work minus half K. K is 20,000. X2 square minus X2 is here. X1 is a substitute. Entire system comes to rest. So T3 is 0. Minus half into M. M is mass of pen and the block 40, 30 plus 10 into its velocity just after that 4.743 square. So if you solve it and simplify it, you get the value of x as 0.2276 meter or 22.76 centimeter. So maximum deflection or maximum compression or deflection or compression of the pen is 0.2276. So here also we have applied, it is a three-stage working in the problem. First stage is work energy principle, second stage is impact, third stage is again work energy principle. So sometimes we come across two-stage problem, sometimes we come across three-stage problem. Okay, now we take another problem, which will also be a three-stage problem. It will be first work energy, then impact, and then again work energy. This problem also has been asked many times in our examinations. Block A is released from rest in position 1. This is position 1. This block is released from rest and slides without friction until it strikes a ball of simple pendulum. Knowing that coefficient of restitution between A and B is 0.9, determine number 1, velocity of B immediately after impact. Second, maximum angular displacement of the pendulum. Mass of block A is 1.125 kg. Mass of ball B is 1. This problem is quite identical to the previous problem. Angle theta, what we got it in the previous problem, same way we get it by applying work energy principle. In the previous problem, it was given directly, you are given with the velocity of the bullet with which it will hit the ball or of simple pendulum. Here first you have to apply here work energy principle so as to get the velocity of the blockage just before impact, and then you will be taking up impact between A and B, and then again you will take work energy principle to get the maximum angular displacement. This block slides without friction from 1 to 2 position. So we draw the another diagram. We write this is position 1. We write this is position 2. All right. This block A slides without friction by and vertical displacement between two positions 1 and 2 is 0.6 meter. This is radius 0.6. That means this is 0.6 meter vertical. Impact between A and B. Taking towards right as positive. Sorry, mass of block A is this, mass of block B is this, and this is E is 0.2. So first we apply work energy principle from 1 to U12 is T2 minus T1. What is mass of block A? 1.125 into 9.81. This is weight. Vertical displacement in the direction of weight is 0.6. So work done is by weight is possible. Is equal to change in kinetics half into 1.125 into UA square minus U. So you get UA 3.43 meter per second. So this is velocity of the block A just before. All right. Now we come to impact between A and B. Taking towards right as positive, UA is 3.43, UB is 0. MAUA plus MBUB is equal to MAVA plus MA. MA is 1.125 into its velocity 3.4 plus MB is 1.8 and Bob is at rest, ball is at rest, so velocity is MA 1.125 VA plus MB 1.8. So you get one equation 1.125 VA plus 1.8 VB is equal to 3.86. E is 0.9 is equal to VB minus VA upon UA minus VB minus VA both are known. UA is 3.43, VB is 0. So VB minus VA 3.0. Solving 1 and 2, you get the value of VB and VA. We are not needing the value of VA, so simply we have recorded solving equation 1 and 2. VB is 2.51 meter per second. Now we apply work energy principle between 2 and 3. See, after the block A hits the ball B, it gains some velocity of 2.51 meter per second. And then it will continue to swing till it comes to rest. At that stage, this angular displacement theta will be maximum, right? So we apply work energy principle from 2 to 3. In this right angle triangle, this diagonal length is 0.9. So this adjacent will be 0.9 cos theta. From here to here, it is 0.9. So this vertical displacement between position 2 and 3 is 0.9 minus 0.9 cos theta, as in the previous sum. Now U23 is T3 minus T2. Here weight of the ball B will do negative work. 1.8 into 9.81 is its weight. 0.9 minus 0.9 cos theta is vertical displacement. Work done will be negative. T3 is 0. T2 is half into M into 2.51 square. 1 minus cos theta is this value, then cos theta, and then theta is square. So when this ball B of the simple pendulum comes to rest, angular displacement theta is 49.9. So in this problem also, we have come across 3 stages of the solution. First stage is work energy principle to get the velocity of blockage just before impact. Then we have considered direct central impact between A and B, and then we applied work energy principle on ball B so as to get the angular displacement theta. Let's move to the next sum. Let's read the same. A ball of mass 1.5 kg is suspended from the ceiling by a 1 meter long elastic cord. If the cord is stretched downward 0.25 meter and the ball is released from rest, determine how far the cord stretches after the ball rebounds from the ceiling. The stiffness of the cord is K, that is 800 Newton per meter, and coefficient restitution between ball and ceiling is 0.8. The ball makes direct central impact with the ceiling, that means ball hits the plane at 90. So that we can take its velocity after impact E times. G is 10 meter per second square. So now let's come to the solution part. E is given 0.8, K is given to us 800 Newton per meter. Let's first understand what is elastic cord. I have written it also as a note in the side. Elastic cord has one-way spring action only when it is stretched. So students, normal spring will do work when you stretch it. You compress it, the work will be done by the spring force. But elastic cord is something stretchable cord, right? So elastic cord, if you stretch it, there will be work will be done. It has spring action. I mean, work will be done by this elastic cord, the force of the elastic cord. But can you compress the cord? No. So you have to remember that this elastic cord will work as a spring only in one direction. So elastic cord has one-way spring action only when it is stretched. Now come to the first stage one. This is the cord of 1 meter length to which a ball is attached. Ball is pulled down by 0.25 meter and then the ball is released from rest. When ball is, so we'll apply work energy principle here from position 1 to position 2. In position 1, velocity of the ball is 0. In position 2, velocity is right. Now, ball travels from position 1 to 2 position by 1.25 meter. When the ball is in position 1, deformation of the or stretch of the elastic cord is 0.25 meter, that is the cord is x. When the ball is in position 2, deformation of the cord is nil because the cord becomes loose. U12 is T2 minus T2. Weight of the ball will do negative work. Weight is downward 1.5 into 10. G is given as 10 into 1.25. Weight downward, displacement upward, so work is negative. Minus half K. It is jara galti se equal to sign aa gaya, minus sign. Minus half K, x2 square minus x1 square. K is 800, x2 is 0, x1 is 0.25 is equal to half into m into v square minus 0. See, initially T1 is 0 since starts from this. In position 2, velocity is 0. So this way, students, we get v is equal to 2.89. What is v? Velocity of the ball in position 2 just before impact. Just before impact. Now, what will be the velocity of the ball just after impact? Since it is direct central impact, it will change by e times 2.89 into e is 0.8. So what is velocity of the ball just after impact? 2.31 meter per second. Then this is plain. In this position, velocity is 2.31 meter per second. Again, after impact, the ball will continue to go down. Length of the cord is 1 meter. Till it goes down by 1 meter, there is no deformation, there is no stretch in the cord. Now, but further the ball will continue to go down till it comes to rest. So we identify third position when the ball has come to rest, right? Let x be the maximum stretch of the cord. Let x be the maximum stretch of the elastic cord, but that will be stretch will be beyond 1 meter because 1 meter was its original length. All right. Now, when the ball is in position 2, deformation of the cord is 0 since it is loose. In third position, deformation of the cord or extension of the cord is x. So x is x. Let's apply work energy principle from 2 to 3. In position 2, it is after impact, velocity of the ball is 2.31 meter per second. In position 3, ball comes to rest when the deformation or extension of the cord is x. Weight of the ball will do positive work 1.5 to 10. Displacement is 1 plus x minus half k. X3 is x square, x2 is 0 is equal to T3 is 0, T2 is half into f into x square. This way, you get the value of x 0.2375. So in this problem, you have come across elastic cord. So you should remember that elastic cord has one-way spring action, and that is only when it is stretched. So when it is stretched, then it works as a spring. When you cannot compress it because the cord becomes loose. That is what is the difference between elastic cord and the complex. All right. Now, students, we have completed the impact problems. Initially, we did direct central impact. After that, we took problems of oblique impact. Then we took up the problems of combined concept. So this way impact concept is completed. Now in this part, as per our syllabus, there is small part written, although they don't ask the question normally from this part. What is impulse momentum principle? Now this impulse momentum principle, in theory, they have asked it once or twice, explain once impulse momentum principle, or describe, or write a short note on impulse momentum principle. This principle relates the force during impact and the time of impact and masses and velocities as well. You saw that the previous methodology of impact, what we use two formulae. One is principle of conservation of momentum, another is coefficient of restriction of form. Right? In this part, the quantities or the parameters which are considered are what? Force, time, mass, and velocity. Now, it is used to solve problems involving force, mass, velocity, and time. This principle is particularly suitable when large forces act for a very small interval of time. And such a force is only called as impulsive force. Any force which acts for any force which is of big magnitude and it acts for very small interval of time, it's called as impulsive force. All right. So here we derive impulse momentum principle from Newton's law. F is ma, a is dv by dt. So we can take dt on the left hand side. F dt is equal to m d. Integrating both sides from time t1 to t2. So f t1 to t2, here v1 to t2. F dt, this becomes delta t, m dv means v, limits v2 minus v. So m v2 minus m v2. So right hand side becomes change in momentum. Left hand side is what? Product of force and time. Right? This is called as impulse of the force. What is impulse of the force? It is the product of force and the small time for which the force is exerted. So this is called as impulse momentum principle. Impulse momentum principle can also be written in component form because V2 and V1 are the resultant velocities of the body. In impulse momentum principle, we consider one body at a time, whereas in the previous impact problems, both the bodies were participating simultaneously. Now in component form, Fx dt, T1 to T2 integration, m Vx2 minus m Vx1. Similarly, F by dt, T1 to T2 in limits of integration is equal to m V by 2 minus m V by 1. All right. So here same thing has been shown, that impulse momentum principle. Here we have shown the force in component form. Here we have shown the velocity in component. Now we'll take three problems on impulse momentum principle. Although it is not that important, although in my book I have given many problems, but here I'll discuss 3-4 problems. Let's see. First, this is the first problem on impulse momentum principle. A ball of mass 110 grams is moving towards a bat with a velocity of 24 meters per second. This is the ball. This is the bat. Ball is moving towards left with a velocity of 24 meters per second. When hit by the bat, the ball attains a velocity of 36 meters per second. The velocity of the ball after impact is 36 meters per second. If the ball and bat are in contact for a period of 0.015 seconds, determine the average impulsive force exerted by the ball during impact. So students, here you will have to apply impulse momentum principle on the ball because there is no information given about the bat. Mass of the ball is given, velocity of the ball before and after impact are given. So we'll apply impulse momentum principle on the mass of the ball is 0.11 kg. Time of contact is 0.015 second. Now Vx1 component of this ball before impact is 24 meters per second to the left, so I can write Vx2 is 36 cos 40 after impact velocity of the ball in x direction. Vy1 velocity of the ball before impact in y direction is 0. Velocity of ball in y direction after impact is 36 sin 40. Based on the sign convention, what he has given. Applying impulse momentum principle in x direction. Fx delta t is equal to mvx2 minus mvx2. Fx is required unknown. Delta t is 0.015 is equal to mass is 0.11 into 27.58, that is vx2. Minus 0.11 mass of the ball into vx1, that is minus 24. So this way you get component of the impulsive force in x direction. Now we apply impulse momentum principle in y direction. Fy delta t is equal to mv by 2 minus mv by 1. Fy into delta t is equal to mass into v by 2 is 36 sin 40, that is 23.14 minus m into e. So you get f. So this way fx and fy are shown to the right direction. Fx is positive, that means 370 to the right. Fy is the positive, that means this is, you get the resultant impulsive force. F is equal to 378 square plus 169.7 square square. You got 414.3. What angle this is a resultant impulsive force makes to the horizontal? Tan theta is Fy upon Fx. Tan theta is 169.7 upon 378. You get the value theta is 24. All right. Problem number 12. A trolley of mass m can move along a horizontal frictionless track. Initially, the trolley, together with the man of mass m1 standing on it, is moving with a velocity v to the right, as shown in the figure. Find the increase in the velocity of the trolley if the man runs with a speed of v1 relative to the floor of trolley and jumps off to the left. Can you see that diagram which is given in the problem? This is the trolley. Trolley, man, all are particles for us. Trolley is of mass m. There is a man standing on it. Its mass is m1. Trolley and man together are moving to the right with velocity v1. All of a sudden, this man jumps off to the left with the velocity of v1. This velocity will be, of course, with respect to man and trolley are moving together as one unit towards right. So initial momentum of the system is total mass of the man and trolley m plus m1. Now let delta v is increase in the velocity of trolley due to motion of man towards left. As the man runs towards left, there will be increase in the velocity of the trolley towards right. That is delta. Now v1. v1 is what? V plus delta. This is V, not V, V1, Vt, velocity, final velocity of the trolley. What is final velocity of the trolley? V plus delta, right? What is velocity of the man with respect to trolley? Vm minus Vt. What is V1 minus? Why minus be written? Since we are taking towards right as possible. So velocity of the man with respect to trolley is minus V1, since to the left. Vm minus Vt. See, final velocity or absolute velocity of trolley due to motion of man to the left is V plus delta. And Vm is absolute velocity of the man. So Vmt is minus V1, Vm minus Vt. Vt value is substituted, we got absolute velocity. So principle of conservation of momentum is applied on absolute velocities or absolute quantity. It is never applied on relative velocities. So V1 is relative velocity of the man with respect to trolley. So as a effect of that, we got the resultant velocity of the trolley. Then we got the resultant velocity of the man. So our absolute velocity of the man. Final momentum after motion of man to the left. This is the mass of the trolley into velocity of the trolley. We substitute. Here mass of man and we substituted velocity of the man. We opened out the bracket mv plus m delta v plus m1v plus m1 delta v minus m1. Equating one end. This is one and this is two. Left hand side term mv gets cancelled, m1v gets cancelled. Left hand side becomes right hand side delta v we take common m plus m1 minus m1. If you further rearrange the terms, delta v is m1 v1 upon m plus 1. So this way, students, we arrive at a formula in this type of problems, right? Delta v is m1 v1 upon m plus m. See, m1 is mass of the man, m is mass of the trolley, v1 is relative velocity of the man with respect to trolley, delta v is increase in the velocity of the trolley. Mind it that if v1 is to the left, delta v will be to the right. Above formula can be expressed in terms of displacement also. So delta v can be written delta x upon t, m1 upon m plus m1, v1 can be written x1 upon t. T gets cancelled, you get the new formula delta x is m1 x1 upon m plus m, where m1 is mass of the man, m is mass of the trolley. X1 is relative displacement of the man with respect to trolley. Delta is x is increase in the absolute displacement trolley in opposite direction. So we can use this formula directly if the weightage of the problem is less. If the weightage of the problem is more, this formula should be derived in the examination. Let's say 13 sum. A man of mass 75 kg and a boy of mass 25 kg dive off the end of the boat of mass 200 kg, and so that their relative velocity with respect to the boat is 3 meters per second. If initially the boat is at rest, find the final velocity if the two dive off simultaneously. Second, the man dies first, followed by the. Now, when two dive off simultaneously, v1 is the relative velocity of the man and boy with respect to boat. Here the motion is between the man and the boat and boy and the boat. So man and the boy can be clubbed. Their relative velocity is say 3 meter per second towards gravity. So we wrote it as m1 is 75 plus 25, that is 100. M is mass of the boat. So delta V is what? M1 V1 upon M plus M. M1 is 100 into 3 upon 200 plus 100, that is 1 meter per second. Final velocity of the boat will be, as the boat was initially addressed, 0 plus delta V, 1 meter per second. Now, second part, when the man dives first, followed by the boat. So again, we assume that V1 is the relative velocity of the man with respect to boat is 3 meter per second to the land. First, we consider effect of the man's diving. M1 will be 75. M is 200 plus 25. See, mass of the boat was 200. But boy is stationary in the first case. So 225. Mass of the boy will be added up to the mass of the boat. So parent's body mass is 225. Floating mass is 75. Delta V1. M1 V1 upon M plus M. So M1 is 75 to 3. V1 is 3. This is M is 225 plus 75.75. So as the man dives to the left with the velocity of 3 meter per second, there is increase in the velocity of the boat in opposite direction. Now the effect of boy's diving. Mass of the boy is 25 kg. Mass of the boat is 200 kg because the man is already off the boat. Delta V2, M1 V1 upon M plus M. M1 is 25 into 3. 3 is delta, the 3 is V1. This is M 200 plus 25.33. So as the boat was initially at rest, so final velocity of the boat will be 0 plus delta V1 plus delta V2. Delta V1 is 0.75, delta V2 is 0.3, 1.08 meter per second. Now we come to the next and the last problem. A boy having a mass of 60 kg and a girl having a mass of 50 kg stand motionless at the end of a toboggan which has a mass of 30 kg. If the extreme position determine the final position of the toboggan, neglect friction. Now you can see what is toboggan. Let's first understand what is toboggan. Toboggan is something like a small boat which is used in the ice. Toboggan is a small boat, lightweight boat which is used in the ice. Now this is toboggan. This is ice level. Boy and girl are standing at the opposite end of the toboggan. They are 1.5 meter apart. The boy goes to the right and to girl's position, girl comes to the boy's position. That means the extreme position. So what we consider, our formula gives you motion of one person at a time. So we'll calculate the effect of the motion of one person. First we'll consider the effect of boy's motion to the right. Then we'll consider the effect of the girl's motion to the left. And then as the toboggan is at rest, so we'll find the net displacement in the position of toboggan. See that. Case 1. Effect of the boy's motion to the right. M1 is the mass of the boy, 60 kg. X1 is relative displacement of the boy with respect to toboggan, that is to the right. M is the mass of the toboggan, but girl is at rest, so 30 plus 50, 80 kg. Apply delta X1, M1 X1 upon M plus M. M1 is 60, X1 is 1.5, M is 80 plus 60, 0.6428 meter to the right. Now, effect of girl's motion to the left. This time M1 is 50 kg. X1 is 1.5 meter relative displacement of the girl with respect to toboggan. This is mass of toboggan 30 plus 60. Boy is still there on the toboggan. So boy's mass will be added up to the parent body. So M is 90. Again, we apply same formula. Delta X2 is M1 X1 plus M plus M1. M1 this time is 50. X1 is 1.5. M is 90 plus 50, 0.5357. Students, you can observe that initially toboggan was at rest. Effect of boy's motion on the toboggan is that it gets displaced to the left by 0.6428. Effect of girl's motion to the left, that toboggan gets displaced to the right with 5357. You can see that this displacement is more than this displacement. That means net displacement will be towards the left. So net displacement toboggan or the final position toboggan will be, we'll take the algebraic sum of these two values. So this is 0.6428 minus 0.5357, that is 0.107. That means net displacement of the toboggan is 0.107 meter towards. So this was all about the impact and collision chapter. That is the last leg of kinetics of particle. This is third part. Kinetics of particle chapter we have covered in 3 chapters in my book. All right. In the syllabus they give it as one chapter, but 3 different concepts are there. Kinetics of particle in part 1 we had covered in Newton's law or D'Alembert's principle. Kinetics of particle 2 we covered work energy principle. Kinetics of particle 3 in which we considered impact and impulse momentum. All the three concepts were covered in two lectures. So total there are 6 lectures, video lectures are there of the entire chapter. 2 on part 1, 2 on part 2 and 2 on part 3. All right. Now students, for more problems, again, I say the same that you need to refer to my book. Many more solved problems are given, although I'm covering enough number of problems in my video lectures. All right. And if you want to refer to more problems, you can refer my book, right, which is available on Amazon and is also available on local bookstores also. Exams may be descriptive or may involve MCQs. Many MCQs in every chapter are given in my book. All right. And even some practice problems and solved problems are also given in that. Students, please share the QR code of my YouTube channel with your friends so that they will also be benefited, because there is no compulsion to buy the book to watch the video channel. Video lectures can be watched by anybody if he or she is having the QR code of the video channel. So please share it with your friends, right, to the maximum extent so that they will also be benefited with my video lectures, right? And also please subscribe to my video channel, all right, YouTube channel, so that you will keep getting the updates about the new videos when are uploaded. Right. With this, today's lecture, my Mumbai University syllabus is completed. All right. So there is no chapter or lecture left out for Mumbai University syllabus. 100% Mumbai University syllabus has been covered. Now my next lectures will be on autonomous institution lectures like VGTI, SPC or SPIT or Ramarao Adik, right? This kind of, or DJ Sangvi, right? So 8 more lectures are being planned, which will be taken in next 1 week time. So I'm targeting to complete all my video lectures on mechanics by 20th of Feb. All right. Thank you very much.